today, we're focusing on site characteristics and catchment data. These are crucial starting points for accurately assessing annual effectiveness in any water quality project. We'll be utilizing the BMPFast toolbox, a comprehensive resource designed to provide the necessary references and software for understanding water quality assessments and streamlining the permit filing process. Welcome to this module. Our learning objectives for using the BMPFast software are to understand how to navigate through the program and its various worksheets. We'll also be focusing on how to input and interpret rainfall data, as well as applying the correct performance standards. Later, we'll delve into the data fields and library available within the software. The BMPFast software has been designed to improve upon previous input worksheets and functions, incorporating the most up-to-date information from new regulations and practices. Our guidance in developing this tool was to make it easy to use by retaining as much acceptable information from past software as possible. It's also designed to be flexible, allowing it to respond to the varying conditions within different water management districts and the FDEP. Finally, much of the information and structure is based on the existing applicant handbooks. For this specific learning module, our primary focus will be on software navigation, understanding rainfall data, and applying the appropriate performance standards. When considering what should be included in an effective toolbox for stormwater management assessment, several key elements stand out. First and foremost, there is a clear need for consistency in how we assess any stormwater management plan, especially for ERP applications. This consistency is not only vital for regulatory compliance, but also proves incredibly helpful for other permits related to flood control and consumptive water use. This is precisely why we've developed systems like BMPFast, to ensure that all applications adhere to regulations and good practices uniformly across the state. Secondly, our tools must be able to incorporate and give credit to creative solutions. We want to encourage innovative designs rather than just standard approaches. Think about examples like green roofs, depression storage or rain gardens, pervious pavements, various filters and swales, water harvesting systems, exfiltration trenches, vegetated filter strips, and even tree wells. The robust software package should include all BMPs currently acceptable to regulatory interests and consultant preferences, providing the flexibility to explore these creative options and achieve annual effectiveness. Third, it's absolutely crucial that our applications are based on Florida's specific conditions. We can't simply use tools designed for different climates or enforcement programs. Their effectiveness needs to be gauged annually, specifically within the Florida context. Any assessment of loadings and BMP effectiveness must be firmly rooted in Florida's unique land and climate conditions. Finally, the toolbox should support professional discovery and a deeper understanding of hydrologic events. This leads to what we call better design. For instance, understanding the benefits of disconnected impervious areas can significantly improve overall stormwater management. The goal is to facilitate good practice and allow professionals to discover different options to achieve that crucial annual effectiveness. When selecting software to evaluate stormwater best management practice systems, several critical considerations come into play. Primarily, the software should be tailored to the specific local conditions where it will be applied. This means it needs to utilize actual Florida rainfall data, accurately reflect Florida's diverse soil types and physical land use conditions, and incorporate event mean concentration data derived from Florida-based studies. These localized inputs are essential for generating reliable and accurate evaluations. Beyond local data, the software must be robust enough to incorporate and evaluate the removal effectiveness for a wide range of stormwater solutions, including traditional structural BMPs, green stormwater infrastructure, and low-impact developments. It should also be capable of assessing how effectively these BMPs perform when arranged in both series and parallel configurations, which is common in real-world applications. Another crucial factor is the software's credibility and acceptance within the professional community. A robust system will have undergone peer review by professionals, ensuring its methodologies and results are sound. This professional acceptance extends to practicing engineers and critically to regulatory and review professionals at local, regional water management districts and the Florida Department of Environmental Protection. Such widespread acceptance helps ensure that your evaluations will be understood and approved. Ultimately, the right software should facilitate the timely completion of your environmental resource permits, making the entire process more efficient. We've designed BMPFast to encompass all these essential features, providing a comprehensive and reliable tool for your stormwater system evaluations. The BMPFast software you're about to use is built on a robust foundation, incorporating regulatory and practice information through 2025. This development involved many professionals in determining key aspects, and 30 individuals provided valuable input during its beta review. It's crucial to understand that BMPFast functions primarily as an assessment model. It is not intended for design purposes. Nevertheless, by observing changes in data and carefully reviewing the generated graphs, users often discover insights that can lead to more cost-effective designs. The version you'll be working with is the latest release, dated April 3, 2026. Please remember that you, as the user, are fully responsible for all input data and for interpreting the results. Finally, once you have registered, you'll have access to a secure software system, which is accessed using your unique email address and a key code. Here we're looking at the data input and navigation within the software. The system is structured around various worksheets, which you'll use to enter your data and subsequently retrieve results. You navigate between these worksheets using designated buttons. On this initial screen, you'll notice only one button is active, or lit, indicating that your next step will be to enter catchment data. Buttons that are not lit are currently unavailable for use. Data entry itself is flexible. Some data cells offer limited choices, which you'll select from drop-down menus, while others are open response boxes allowing for unlimited entries. This particular screen is your first worksheet, designed for general site information. Here, you'll input critical details such as rain statistics, define your performance criteria, and indicate whether you'll be conducting a groundwater discharge analysis. You'll also provide a name for your project. It's crucial that the selection of the performance standard for your watershed site adheres to the specifications outlined in the Applicant's Handbook, Volume 1, Section 8.3. Each site is uniquely identified by its Hydrologic Unit Code, or HUC-12. Additionally, throughout the software, you'll find help buttons, marked by a question mark, and references that provide more general documentation and aid in understanding the system. Here we're looking at the General Site Info worksheet within BMPFast, which allows you to set up your project's foundational parameters. First, you'll need to enter the rainfall zone, choosing from one of 5 options, along with the average annual rainfall for your project area. There's a comprehensive library of support information available to assist you with these inputs. It's also crucial to give your project a clear name here, as this will be used for all printouts and summary reports generated by the software. One of the key aspects you'll configure on this worksheet is the performance standard, which is typically determined by the specific body of water to which you'll be discharging. You'll find 7 distinct choices available in the drop-down menus to select the appropriate standard. In addition to these, you might need to specify a particular percentage removal for pollutants, or you could opt for a net improvement standard, where post-development pollutant loads must be less than or equal to pre-development loads. This net improvement can sometimes be a standalone standard, especially for local pollution control programs. The software also offers the flexibility to conduct a general BMP analysis without necessarily specifying a removal percentage or net improvement up front. A unique feature of this software is its ability to analyze potential groundwater impacts, which you can access and configure through a dedicated drop-down menu. Throughout this worksheet, you'll appreciate that you can change any input at any time without having to reload the entire system. We will now take a brief pause before continuing with the next section of our course material. Here we're looking at the 2024 annual rainfall volume. You can find a detailed map of this data in Appendix M, specifically Figure 2, which provides the official 2024 rainfall information. This resource allows us to determine the annual rainfall for various locations by referencing the map. Here we are comparing the annual rainfall data from the year 2000 with updated information for 2024. The 2000 data, often referenced from Harper and Baker's 2007 publication, is being examined against new annual rainfall depths published by NOAA in 2022, which are the 2024 values. The numbers you see in the boxes on the map represent these new annual rainfall depths for 2024. Upon comparing these datasets, we observe varied changes. Some annual rainfall amounts are now greater, some are smaller, and others remain relatively equal compared to the 2000 figures. It is critical to use these updated 2024 rainfall maps and their associated data. Furthermore, any software used for analysis or design must be capable of accepting these new annual rainfall depths from external sources, especially given the expected changes in these maps over time. Most importantly, this updated 2024 annual rainfall data must be incorporated into any permit applications moving forward. By selecting Yes for groundwater analysis, we are confirming its inclusion in our current assessment. It's important to note that, for this particular example, our performance standard remains unaffected by any impaired water or outstanding Florida water classifications. Now that all initial choices and data have been entered, your next step is to proceed to enter the catchment data by clicking on button number 1. To begin, you will enter the catchment data as shown. A catchment, in this context, refers to the area contributing runoff water, and it's also the potential location for a best management practice or BMP. You have the flexibility to add other sources of loadings to these surface loadings if needed. You'll notice a yellow Help button, which is available to assist you in identifying the correct land use for your data entry. Additionally, there's another learning module that can provide further aid in defining land uses. An important feature to note is the user-defined value for the post-land use. This is particularly useful when you have site-specific study EMCs, or if your catchment is composed of multiple land uses with different EMCs requiring a composite EMC. Adjacent to the post-EMC values, you'll see a yellow plus mark. This plus mark indicates a calculation routine is available for handling multiple EMC values within your catchment, and clicking it will reveal an open entry shown in white. Once all the necessary data has been entered, you will first hit the Calculate button, and then proceed to enter the Back button. Once you've entered the site and watershed characteristics, the next crucial step is to enter the Treatment Best Management Practice, or BMP, data, and configure your catchments. Within the configuration stage, you'll be able to select the flow of water and assign either a single BMP or multiple BMPs in series for each specific catchment. It's highly recommended to undergo training for this process, as a basic level of competency will significantly help in reducing requests for additional information, or RAIs, and ensure that you can obtain your permits in a timely manner. Remember, it's always good practice to save your project frequently. This allows you to recall your work easily without having to re-enter data. Be aware that clicking the New Project button will conclude your current project and allow you to start a fresh one, while the Exit button will completely terminate the project and the software, requiring a full reload if you wish to continue your work. We've covered quite a bit in this module. You've now gained practical experience in navigating the software, understanding the formats for rainfall data input, and becoming familiar with performance standards. This hands-on experience has introduced you to the type of site-specific and watershed characteristics data essential for annual water quality assessments. We also discussed catchment characteristics and the various data fields, along with the extensive library of information and computational aids built into the system to assist you in defining this data accurately. It's highly recommended that you explore the other learning and training modules available. Opening each of these will significantly deepen your understanding of the possibilities for water quality improvement using best management practices. Finally, pursuing basic competency certification is a valuable step. This certification will establish your superior credentials, which in turn can help reduce requests for additional information during permit submissions. ultimately leading to faster permit approvals. These are all key reasons why understanding and utilizing the BMPFast system effectively is so beneficial. This presentation has completed our discussion on understanding site-specific and watershed characteristics data, along with navigation of the BMPFast software. We encourage you to view our other learning modules and apply for a certificate of competency once you have knowledge of most of the information presented. For details on the test procedure, please see the module titled Self-Test. There are at least 20 more learning modules available to help you further understand stormwater management for water quality control. Thank you for viewing and listening to this information.